In this video, we're going to take a look at problem number 4 on page 591. So we've looked at the fundamental theorem of calculus and how it's applied when the upper bound of the integration is not x, but some function of x, in this case, x squared. So we did that problem twice, and once kind of gave us a little bit of a sense of how we can use the chain rule to make our lives easier instead of just, kind of rolling it by hand every time. So let's take a look at how we can apply those ideas to problem 4 and make our lives a little bit easier. So what we're going to do is we're just going to jump straight to the fundamental theorem of calculus. So when we are calculating the limit from 1 to some function u of x times f of t dt, that is equal to f of u of x times u prime of x. All right, so what we're doing is we're combining the fundamental theorem of calculus with adding in the chain rule, because it's not varying with regards to x, but with regards to some function u of x. So we need to talk about how u is changing with regards to x. So let's look at this specific case. So f of u of x, so that's f of x squared times u of x, the derivative of x squared with respect to x, which is 2x. And in this case, f of t is equal to 6 times t squared. So this is equal to 6 times the square root of t squared. I'm sorry, not t, but x. So I'm replacing t with x squared in this problem and multiplying that times 2x. All right, and what is the square root of x squared? Careful if you said that's just x, because x squared is always positive. Even if x is negative, x squared is going to be positive, and the square root of x squared is always going to be positive. So that is equal to 6 times the absolute value of x times 2x. And so our answer here is going to be 12 times x times the absolute value of x. Okay? So that was kind of a good deal faster than kind of going through this single case and using the fundamental theorem of calculus along with the chain rule. Okay, so using functions as the upper and lower bounds of a definite integral doesn't happen as often as this lesson would lead you to believe, but it's a good thing to know about. So in the next videos, we're going to go forward on through the lessons and see how to apply these problems in order to solve AP level difficulty problems.